Hey everyone, Sanjay Medichurla here. We're going on to part four of our comp methods video. So in part three, we define this surf function, which gets our surface point of with r of 0.5 away, and now we're going to vectorize this surf function, and then we're going to graph it. And then I think once we graph it, we'll kind of see what we were working towards, right? And so to vectorize this function, I'm going to use this jax.numpy.vectorize. It's pretty powerful thing. I mean, it's probably not how I would do it actually, but I learned that it's very, very strong and very convenient for us to use, right? So what I'm gonna do actually, why are there errors here? There should be no. Okay, good. Um, so I'm gonna say surf underscore vectorize or vector equals jnp dot vectorize. And then what is the function I'm going to vectorize? I'm going to vectorize surf, of course. And then these little, what's it called? Um, Arguments I always forget, but it's so you can size your, it's so you can size your vector, right? And then real quick, so I've created a vectorized form of the surf function. And so what does the surf function take in? T and theta, right? So what if I just say surf uh, A equals surf underscore vector at T and theta, so 0 and 0, and then run. And then what if I printed A actually? Let's see what happens. Um, so we get the same, we actually get 2.5, 0, and 0. Why is that? What did we print? Oh, it's because we printed np.pi last time. So if we make this 0, it's going to get the same exact thing as surf. But the cool part of this vector is I don't have to stick to just one value anymore. I can sort of graph everything like how we did prior. So what I'm going to do is I'm actually just going to graph t and theta in A straight up. But clearly it doesn't want me to. Oh, surf vecto. My bad. We're dropping letters around here. Surf vector. Oh no. So incompatible shapes for broadcasting. So why don't we fix that? Um, what I'm gonna do is I'm going to essentially uh, make the shapes quote unquote able to broadcast by I'm not actually changing the shape of anything, but we're gonna do a little bit of a clever trick here. So I'm gonna start from the beginning all the way until none. So where it reaches until the end. So now this is becoming a range, right? A range of 100 values, or maybe range is the wrong data type, but 100 values, yeah. And then I'm gonna do the same thing here. Um, and now let's print A. See what happens. Look at that. We have our array 2.5, 3.5. So for different values of theta, right? That's what's happening. So that 3.5, this whole set was when it was pi over 2. Um, so here we go. Print a, and then so I'm going to say x, y, z equals a. Uh, is that not going to work? I feel like that's not going to work. Too many values to unpack. Expected 3. Um, so what if I changed it the other way? Okay, so we did the transpose so we can actually unpack it, right? Um, and then so once we did that, we have values for x, y, and z. And then now using the same ideology we did earlier, we can graph it. So, um, since I already wrote it once, there's no point in me trying to write it again. Uh-huh. So x equals. So let's see if we can graph it like this, and then what happens afterward. So nothing seems actually no fig. I want you to graph the actual figure. Come on. Okay. I don't need you right now. How can I comment you out? Um, no, stop. Cancel. Um, I was going to demonstrate why this didn't work, but clearly it's not even plotting anything, which is uh, so. What's the problem? It just kind of did it last time. What if I say print fig? Can it do that? Or like show print fig? I don't know if you can actually print a figure. Um, anyways, the point is, we when we do this figure, we can't actually do this because x, y, z. So like if I look at the size of x, it's gonna be I think 100 by 16 or something like this. So it's not conducive uh, to do that. So if, what I'm gonna do is if for I in um, range theta, for I in range theta, x, x I, y I, z I. Let's just try graphing this. What's wrong here? Wait, for I in range theta, yeah. Expected another intent. Okay, but that's not a real error. Come on. I got him. Um, only integer. Not range. Oh god, it should be size. It should definitely be size. Oh, size. Or I'm messing up my syntax between languages here. It should maybe be theta dot size. Still, the int object is not iterable. For I in, you know what? We went the whole long way there. That was pretty poor. I'm not gonna lie. Um, but there you go. Though I'm not sure why the figure itself is not plotting. Let me let me check that. Um, I know. Let me check that. Let me pause the video, check that, and come back to you. Okay, so we're back. I figured it out, but there's one thing I wanted to say. So I think first it's kind of cool for us to look at x dot size here because I actually forgot something, and that's because we never looked at it. Uh, oh, it's because I never finished this. Um, well, I'll explain this in a second, but we don't want them to be any errors, and this isn't callable. That was also an issue. Come on, just show it to me. So let's print x dot size, get an answer. Right, 1600 because it's 16 multiplied by 100, yeah? Uh, so, what if I just print x itself? There's something I wanted to show in particular. Okay, yes. Um, this is what it is, right? So it's an array of like a bunch of entries, and then we want to hold when we iterate through it, we want to hold all the values of t and change all the values of theta. So that's why I had to add these colons, right? And then so when I graph this figure, we should get a bunch of lines, kind of like a revolution, a solid of revolution around our original curve. So what do you look like? There we go, right? So a bunch of different x values for different theta values. Because remember, in the last example, we were showing how uh, you took the center. So I wonder if I can actually find the center on here. Which one was the one that was mine? So trace 2, trace 3. Where's the original? Okay, well, we have the original up here, if I can zoom out of it. And then so we are just replicating the curve a bunch of points around that, right? But we're not done. We're not done yet here. We can do the same little exercise that we've done, except for t, right? And then what's this going to do? It's going to form actual circles instead of lines. So I'm going to make this t dot size, and then um, run it. Mm, It's a big. Wait, what the thing happened? Except it got more. Oh, that's because I did. I have to change it like this. Ah, yes. I just explained this a minute ago, but yeah. So now I want to hold the theta fixed, and I want to change the t. There we go. We have our circles. Uh, so we can see all the circles that get formed. Is this right? Yeah. All of the circles that get formed are helical pipe, and kind of what we were going for with this entire example. So I hope this video series was informative to you guys. It was certainly informative to me. I didn't know anything about this beforehand. And yeah, that's all I have. Thank you.